okay, which is again on the introduction to control system. And then what I have said yesterday, I want you to do the revision on the your Laplace transform, because that is the fundamental of this subject, this class. Okay. Okay. My name is Soleh. You can call me Dr. Soleh. This is my room number, level 16, room 14A, and then my phone number. This is my email. Okay. Okay. Now we talk about the control system. Okay. This the process to be controlled. What I'm trying to say here is control system is a process to be controlled. We have here input and output, and the process inside it is okay. This is the process. Okay, the process. We have in, we have output, input and output. Okay, input, we have output, and then whatever in the box is the process. Okay, the process to be controlled. So engineering is concerned with understanding and controlling the material, okay, and process of nature for the benefit of humankind. So control system engineer, what control system engineer doing? They are concerned with the understanding and controlling segment of their environment. Okay, so this is what we often call as the system. Okay, and it is useful. It provides a useful economic product for the society. And what is the basis? What are the basis of control engineering? What is the basic foundation of it? So the foundation of it is of feedback theory. Okay, this is the thing, and then linear system analysis. Okay, so you need to have feedback theory and linear system analysis. So you need to recall what you have learned in linear algebra, okay, matrices, okay, and you integrate this concept with a network theory and communication theory. So meaning you have whatever you learn in mathematics, especially on the feedback theory and linear system analysis, and then you will integrate it with the concept of network theory and communication theory. Okay, so this is what I have said yesterday. Control system is an interconnection of the component to form a system configuration that will provide a desired system response. Okay, and it is it's used linear system theory, and what we will have here is the cause and effect relationship. Okay, cause effect. Okay, the relationship of cause and effect relationship for the component of the system. Okay, so if you look at this figure, the input output relationship represent the cause and effect, okay, of the component or process to be controlled. Okay, now we proceed with the feedback control. Let me just recap what I mentioned yesterday. This is an example of aircon. Okay, HVAC system. Okay, the one that we are facing or having it every day. This is an remember yesterday I mentioned about open loop system. So it utilizes an actuating device, okay, to control the process directly, okay, without using a feedback. So this is what we call open loop control system. So the desired output response, what we want, and then we have a controller, actuator, the process, and then the output. This is an example of open air conditioning. Another one is I mentioned is the closed loop. Okay, closed loop control system. This is open loop. This is closed loop. Okay, so closed loop control system use a measurement of the output. Okay, measurement of the output, and then we will have here the feedback of this signal. So it will have a sensor there. So it will compare it to the desired output with the reference command. Okay, we have here the process go this way, controller actuator process, and then you have here the sensor, and then it will give you the feedback. Okay, the feedback uh, of this signal for comparison. So to compare with the desired output response. Okay, this is an example of a float regulator. Okay, so the measurement of the output. Okay, what would be the measurement of the output? So the measurement of the output is called feedback signal. If you still remember yesterday, I mentioned about disturbance and noise. Okay, disturbance and noise. Okay, so if you look at here, you can see this is the disturbance. Okay, external. Okay, we have here desired output response. Okay, controller, and then we we have here what we call a disturbance. Okay, disturbance, and then the process continue actuator, and then we have the process one process there, and then we have the actual output, and then this is the feedback loop, feedback loop here. So we have here the measurement of noise. Okay, this is disturbance, and then this is the measurement of noise, and then we have the feedback, the sensor here. Okay, to have to bring the measurement output. Okay, okay, so we have a feedback system over here. Okay, this is where I locate in this figure we locate the disturbance and noise. Okay, for closed loop control versus open loop control, of course they have their own advantages. For example, for this case, closed loop control has few advantages over open loop control. One of the plus point of it is its ability to reject external disturbance. So we have external disturbance. So closed loop, it has the ability to reject external disturbance, and then also it can also improve, okay, improve the measurement of noise attenuation. Okay, so closed loop has the ability, to reject external disturbance, and also here it will improve noise attenuation. Okay, you can control noise for the case of this example. Okay, so as I mentioned yesterday, disturbance and noise, they are considered as an external input. Okay, this is what we call external input. Okay, another another one is what we call multi-loop feedback system. Okay, what is multi-loop feedback system will be about? So the word multi means what? The word multi. Any comment? Multi.
Several.
Can more than one, right? Can be more than one. Multi. Multi-purpose. Yeah? So if you look at this figure, okay, try to look at this figure on your own. How many feedback loop that we have there? We have there
Two feedback.
desired output, and then we have a controller. Okay, then next box we have controller, actuator, the process, and then this is the actual output, right? This is the actual output, and then you can see we put the first sensor here. The first sensor will give you the first feedback, and will give you the measurement output. Okay, measurement output. Okay, and then this is what we call the first feedback. This one, this is inner loop. Okay, this is what we call inner loop. Okay, this is an inner loop. Okay, yeah, inner loop. Okay, this is inner loop. Okay, and then we're going to have another sensor here. This is sensor one. This is number two, number one. So sensor number two we put here, and then we will have another feedback. Okay, so it will go to the far away from here until it reach here, which is at the desired output response. Okay, so this is number two, and then number one. So this is what we call outer loop. Okay, outer loop, dalam luar, inner loop, and then this is outer. Okay, so when we have a feedback system, not necessarily we have only one feedback. Okay, not only one feedback, but it can be more. Okay, can be more more than one feedback. Okay, one feedback loop. Common multi-loop feedback we illustrate in the figure with we have in the figure inner loop and outer. Okay, and outer loop. Okay, so for this scenario, the inner loop, we have there a controller. Okay, controller and sensor. Where is the controller? Try to find where is it? Oh yeah, this is a controller. Controller one. Then what else? And we also have sensor here for inner loop. And how about the outer loop? We have for the outer loop, we also have a controller. Okay, okay, which is controller, and then we also have a sensor. We have controller one, sensor one, controller number two, and sensor number two. Okay. All right. So our strategy for this class, first of all, we're going to look at the single loop feedback. Okay, as for the learning purpose, about the benefit of the feedback control system, and then later on we're going to extend to multi-loop system. Okay. Next section is what we call multi-variable control system. Okay, more than one. Multi-variable control system. Can look here. We have multi-variable. Okay, different variable to control. So we can have here the first one, first line, first arrow, first arrow. This is first arrow. Okay, and then can have more. Second arrow, third arrow, and then we can also have several feedback system. Several feedback system. One here, two, three, and then we'll give the feedback, the measurement output. Okay, measurement output, so that you can do the comparison. Okay, this is the diagram for multi-variable control system. because when you try to build up the system, you start with the simple one and then slowly you increase the complexity of the system. Selalu macam tu lah. We start with the simple one when you do the analysis, skeleton, and then slowly we increase one, two, three, uh, to due to the complexity of the system under control, okay, and our interest uh, for us to achieve, because at the end of the day, we want to have what we call the optimum performance. Okay, the keyword is optimum lah, optimum performance. Okay, this is what we would like to achieve. That's why we start with the simple one and then slowly we increase the complexity of the system under control. Okay, so this is the importance of control system. How sensitive it is, the sensor, for example. Depends on your budget and depends on the objective, what you want. Yeah. What you want. You want it more sensitive, so is it necessary for us to spend much more money for the sensor so that will give you the good performance, optimum performance or the best performance. It depends on the problem statement and the outcome or objective given by your company or your boss or on by your customer. Okay, and then furthermore, system become more complex. Okay, and the interrelationship of many control variables must be considered in the control scheme. Okay, so that's why we need to learn how to do a programming. Okay, so that it can solve your the different variables they can use programming language to solve the problem. Okay, write a small coding and then try to solve the problem given. Okay. Bit on history, okay, sejarah of the automatic control. It has been there for quite some time, long time ago, before Christ. 300 before Christ, we have a flow regulator mechanism used in Greece. Okay, I have been in Greece, I think been in Athens, 2005. I went there. Very old country, one of the backward country in Europe. But they have a very good historical site to visit there. I went there for a conference. And then back in the 1572 and 1633, this is a Dutch temperature regulator invented by Cornelis, okay, Drebbel in Holland a long time ago. Okay, and then this is another example of automatic control. And then another one is pressure regulator, okay, by Papin, 1681 for steam boiler. Okay, and then fly ball governor invented by James Watt. Okay, to control the speed of a steam engine. Last time they have a steam engine. Okay, this is how the system looks like when we talk about the engine. Last time we have a steam engine, have a boiler, and then have the valve, and then we have the connector bring it to the engine, and then we have the wheel over here. Okay, and then this is output shaft. Okay, shaft we have the governor, metal sphere, and measured speed here. Okay, okay, and then another one, see Maxwell formulated mathematical control. Okay, 1868 formulated the mathematical model, the control theory, okay, using differential equation model of governance. Okay, okay, and then prior to World War II, control theory was developed. We continue to develop more advancedly in America using frequent domain. Okay, frequency domain. Okay, in America they use a frequency domain after World War II. Okay, and in Europe they still use a time domain. Okay, And then when the start of digital computing, so start in 1980, they start to have digital computer to be used in control component. Okay. This is a bit on the chronology of the advancement of the automatic control. Next one is example of car steering control system. Okay, this is the car. We have the car. The example of car steering control system. Okay, this is actual this arrow, actual direction of travel, and then actual versus desired direction of travel. Okay, so we plot the graph. We will have the desired versus time. Normally, what we desire, okay, what we plan, what we plan versus we have actual desired. Okay, desired is what we plan to, what we want, and then in actual in reality, what happened, versus actual. Okay, sometimes it goes smoothly. Our plan goes smoothly. Okay, okay, start in the beginning goes smoothly. Okay, and then in actual maybe there are hiccup certain time when there are a lot of unexpected thing happen, unplanned thing happens, disturbance, noise, but at the end of the day, alhamdulillah, we're going to achieve our destination. Okay, so in between we have uh, the the error in between, or the one which is not the same like what we plan, what we plan. That's why we call error here. Okay, error. So we look at here again. Try to look at this box. We start with a desired cost. Okay, we have a desired cost of travel. Okay, and then this is an actual one versus time. Okay, versus time. Respond direction of travel versus time. So what we have here, when you start to drive, control system. Right now we don't have the future of the car. They don't have the steering. This is we have a steering control system. The driver, we have a steering mechanism. Okay, steering mechanism to move right, left, and then the car start moving. Okay, and then what we have here in between is what we call a measurement, visual and tactile. Okay, so this is the feedback over here, measurement. We have a measurement, and visual, and tactile. Okay. Another example is three-axis control system. Okay, we have axis x y axis. This is z axis motor. This is wafer. Uh, this is old figure of computer. Used to be like this, now flat screen. And then we have x-axis motor, y-axis motor. Okay, this is what we call a three-axis control system. Okay, so again we have here a reference input and output. Okay, and then the computer, and then the computer control, and then they have the actuator, the process, and then start taking the measurement, give the okay. Okay, this is your assignment. I want you to do a group assignment. Group assignment comprised of how many of you now? 21, two classes. I hope you have two classes. Okay, let me see. Each class you have how many? 14 in one class. 14. Another class, let me see. This is 4B, you have 17. Class 4B, 4B2. Oh, 14, 14, 4B2, 14. 14, 4. So one class we will have what, three groups? Three groups. So let me see which group. Group for this is group 4B2. How many students we have in this class? Let me see. 14. We have 13 students. Okay. Then this is 4B2. And then 4B1. 4B1 you have 10. 4B1. 10. Okay. 10 students. So this is a group assignment. You want you to form a group. So 3 to 4 students per group. 3 to 4. Okay. Because EAC, they don't want you to have a group more than 5. So 3 to 4. Okay. Because we don't want to violate the student per group for any project. Okay. Okay. So we have here, you familiar with this? Okay. This is what we call a float regulator. Okay. This one is one of the automatic control system that been used a long time ago. Okay. Long time ago. So we utilize this in our daily life. Okay. For daily life. And it is available in our pilot flight. So what I want you to do, okay, is for you to study the configuration of the fluid regulator mechanism in your toilet and analyze its component. Okay. Tengok dia punya configuration, dia punya mechanism. Okay, and then you analyze its component, and then you rewrite each text in the block diagram shown below with the suitable component or parameter name. Okay. Okay, this is one. And then number 2, explain the working principle of fluid regulator mechanism. Okay. And then I want you to discuss in group and write a report in master Microsoft Word, and then you submit your this first assignment in our Google Classroom. I will give you the link later. Okay. So we have here desired output, comparator, controller, process. We have a Twitter here, and then have a feedback. Basically, is not here. This is here. Okay. Okay. So for the feedback, basically, okay, this is a correction of this. Okay. So we stop our class today, and then we come back at 3:10. We come back at 3:10. I want to give you the briefing of your lab. Okay. I'll see you at 3:10.
Thank you, Doctor.
You can fill up our attendance thing today.